Hi everyone, I'm back to see you again, online. So let's move right away, right? So yeah, let's continue from yesterday, right? I was so sorry. I was so sorry yesterday. I got a phone call and I had to stop. I had to stop it in a midway like that. Okay, let's see, right? So today we will talk about this square matrix, square matrices. Okay, so what is different of the square matrices from the other original like metrics, something like that, right? So you have to look at it. So as the name stated, right, the word like square means if you think of a box, that box has all the sides like equal, right? All the sides equal. The length of each side, all of them are equal. And here, right, when we talk about a matrix, like matrix has the row and the column. So the key is the square means the number of rows must be equal to the number of columns, something like that. Yep. So I would say number of row will be equal to the number of columns. So something like this, number one, right? This is a 1 by 1 square matrix. Okay, so you have one row and one column. This one is 2 by 2. So very easy. You have one row, two rows, and then one column, two columns. So the number of rows is equal to the number of columns. Same like this guy, right? 3 by 3. Very easy. 1, 2, 3 rows. 1, 2, 3 columns. Easy. Easy, right? And then let's go back a little bit. Like we see this word, like something like the upper trianglometric and the lower trianglometric, right? This guy, right? So we want to talk about something like this. Something there, right? 2, 1, there. We call them the diagonal of a matrix. So if you go up a little bit, you see the 0, right? And it looks like something like triangle. I'm sorry, my art skill is so damn bad. Okay, I'm so sorry. It doesn't look like triangle at all, right? So that one is, we call it the upper triangle metric, right? And it's a 0. So here down there, right, you have another triangle where we call it the lower triangle matrix, and then it's -1, right? So here, if we come to number 3, right, it's a little bigger, right? That is diagonal. So this will be the uh, upper triangle matrix, right? 2, 1, and -2. And then that is the lower triangle matrix. So that is 5, 3, and 0. Okay, so far so good, right? So as I said in class, if you have any thing unclear, then you can ask me. You can ask me anything. Or if you see me again in class, and you feel like this is so easy, this is too easy for you, you can bring something hard into the classroom, and we can just talk about that. Okay, next one, right? Okay, sorry. Next one is the zero metrics, like the name says 0, right? When you see the word 0, 0 means like you have nothing there, right? But in metrics, it doesn't mean that you don't see anything, it's like invisible, something like that. When we talk about a zero metrics, we mean our meaning is like this, a matrix that has the members inside, but all the members, they are all equal to 0, right? Something like this. This is 1, 2, right? This is 2 by 1, and all the members are 0. All the entries are 0. This one is 1, 2, 1, 2, 3, 3 columns. This is 2 by 3, but anyway, all the members are 0. We call it the zero matrix. Okay, this one as well, zero matrix. Okay, so it's like the vocab is like the keyword now. Today we talk about a keyword so that you will know it when we talk about this one in the class again. Or you see it in the test, you see it in the exam, then you know what is the meaning of those keywords, right? Okay, so next keyword is this one, identity metrics, right? So identity metrics, sorry, something is not okay with mine pen. Okay, so identity metrics, like when something is the identity, what should I say? Maybe I'm gonna explain to you with the example. Okay, so sometimes, like for me, when I understand things, I'd like to see the example. So we talk about, let's say, normal number like this. If you have number 2, right, multiply with number 1. That is equal to number 1. Multiply with number 2, and it is equal to 2, right? So if you say, right, this number 1, right? Whatever numbers that you have, if you multiplied it with number 1, what you have is always the same number. So identity means anything that, I'm sorry, I'm a little bit sick. I have running nose, sorry. So identity means a number that when you use it to multiply with any number that you have, the result is it's the same. The result doesn't change. So we call this one the identity. But that thing is a constant. This thing, number 1, is a number. But here we talk about the matrix, right? We talk about the matrix. The matrix is not a single number. So identity matrix is something like that. You know, a number inside a box like that. A number inside a box. This is called I1. I1 means the identity matrix that has the number of row and a number of column equal to 1. It's like a square matrix of dimension 1, right? This one I2. I2 is the square matrix with the dimension of 2. 2 by 2, something like that. And all the ones are in the diagonal. So this one, right? It's quite like popular. You're gonna see them. You're gonna see this guy like a lot of times. Right? So next one, like I3, same thing, like identity matrix that has the dimension of 3 by 3 square matrix like that. Diagonal, it's all ones. Upper triangle it's 0. Lower triangle it's 0. Yeah, so you know, right? So I think that we will see this one more in the example soon. Okay, so now you just know the keyword. Okay. Next one, let's go for the operation now. Matrix operations. The first operation that we have to deal with is that addition. Addition. And addition is that plus, right? Addition is plus. So it's here like something that you can read them. You can read them by yourself. But I'm gonna go to the example. You know, explain with the example, and I'm gonna write down some rules that you have to know. Right? Two matrices like this, they are able to be added. Like they are able to be added if number 1, right? They have the same dimension. They have the same dimensions. Like, let me write it down. Right, same dimensions. Right. If this is matrix A, that is matrix B. Right. A and B, they have to be in the same dimensions. Like this guy, right? 1, 2, 3, negative 4, 5, 6. We have the dimensions of them of 2 rows by 3 columns. And this guy, right? This guy, matrix B, it's the same thing. 2 row and 3 columns. So they are in the same dimension. So you can add them. You can add them, no problem, right? So when you can add them, you need to know the result. Right? To find the result, rule number 2 is you will add the number in the same positions. Okay, add the number in the same positions. I'm gonna write like say add the same. My image is really bad. Add the same positions. Okay, add the same positions. What do I mean by that? You add the number, something like number 1, right? Number 1 is in the same position as 0. Why? Because number 1 is at the, if it has like an address, you know, the address is at row number 1 and column number 1. You see, right? Row number 1, column number 1. Number 0 is that row number 1 and column number 1 as well, right? Row number 1, column number 1. So they are okay to be added. So 1 plus 0 is a 1. So you're done with that now. And let's go next one, right? Negative 2. This one is at row number 1 and column number 2, right? Row number 1, column number 2. This number 2 again, row number 1, column number 2. The address is like 1, 2. So this guy and this guy, they are at the same locations, so you can add them. Negative 2 add with 2 will become 0. So I think that you see the idea now, right? Very easy. So this guy, like number 3 and negative 1, they are at the same position. So that is number 2, right? If you add them. Okay, negative 4 and 3, they are at the same position. So you add them, you have negative 1. This is 5 and negative 2 you add, you minus them actually. So you will just get number 3 out, right? 6 and 4, that is going to be 10. So that is your result. Okay, answer. So we have like just 2 rules. Rule number 1, same dimensions. If you want to add them, if you want to subtract them, okay, you need to have the same dimensions of 2 matrices. Number 2, when the dimensions are the same, you know that you will get answers, and the answer will come when you add the 2 numbers at the same positions. Okay, so let's go to one more example at here, right? Very quickly. This is plus, this is minus, right? So I go like this, like 1 minus 0, that is a 1 because it's at the same position. They are at the same position, right? Negative 2 minus 2, that is negative 4. 3 minus 1. Minus or minus is a plus. So we have 3 plus 1, right? That's a 4. I'm sorry. I moved my number up a little bit, okay? Okay, next one, right? Negative 4. This is negative 4, that is 3. So we have negative 1. 5. No, that's a minus. I'm sorry. Yay, I'm gonna fix myself. Okay, negative 4 minus 3. It should be negative 7. Okay, go slowly a little bit, right? Go slower a little bit. Okay. 5 minus minus 2. That will be plus 7. 6 minus 4 is 2. And that is your answer. Straightforward, right? Very easy. The idea is the same as when you add ordinary numbers, like any normal numbers, but in this case, we just put all of them in a box, and that box is called like matrix. Okay. You see, right? So metric is to me and to you. It's something so simple, right? Not hard. Okay, next one, right? 1.6. Now we are at the topic. 1.6 is 6 scalar multiplication. Okay, scalar multiplication, right? When you see this word like scalar, if you study a bit about physics, right? I know you study physics, right? And you should be very good because your physics is study, well, very professional, right? So when we talk about something scalar, we talk about the sides. Yeah, you talk about the sides, and it means just actually like a constant. Okay, a size, a constant, a number, something like that. Okay, so multiplication, which is multiply. So the meaning of this one is actually multiplying a number inside a matrix. So how it works like this. Let's see the example below. Okay, number 3, right? This is the scalar. You want to multiply it in that matrix of 1, negative 4. It has 2 rows, 1 column, so it goes like this. 3, right? You multiplied it to number 1, you have number 3 like that. And then this number 3 multiplied to negative 4, it's negative 12. Very easy, right? The key idea, key concept is the same as when you distributive multiply the number into the bracket, something like that. Same idea, right? 3 times 1 is 3. 3 times 4 is 12, something like that. Same. So you have to distribute that scalar to scalar quantity, constant to all the entries of the matrix. Okay, let's go. Let's go to the next one. Right? Negative 5, right? Go to multiply with 1, that is negative 5. Negative 5 times negative 2, we have 10. This is 15, right? With a negative in front, right? This one, negative times negative is positive, right? This rule always holds true. Okay, so we have positive 20. That is negative 25. And that one is negative 30, right? Very easy, right? Very easy. Piece of cake. Okay, so we get next one now. Okay, this is a little bit like harder, but anyway, simple. Okay, you have matrix A, you have matrix B, and then I asked you to do like 2 times of A minus 3 times of B. So let's do it. Okay, we want to get 2 times of A, right? So it's like we multiply 2 inside A. Okay, so 2 times 0 is 0, 2 times 3 is 6, 2 times 3 is 6, 2 times negative 2 is negative 4, right? Very easy. Next one, right? You wanted 3 times of B. So it's like you put a number there, right? 3 times 1 is negative 3. 3 times 1, it's 3. Oh, what is wrong? Okay, 3 times 4 is 12, right? 3 times 0 is 0. And then you just subtract them, right? Position by position. Okay, 0 minus 3, that will be swapped to positive 3, right? 6 minus 3, that is 3 again. 6 minus 12, that is negative 6. Negative 4 minus 0, that is the negative 4. Easy. Done. Right? Oh my God. I'm so alone. I talk alone. I feel like I'm crazy now. Yeah, but soon, sooner or later, we are going to try to develop some system, you know, that you and me can be doing this kind of thing at the same time. I can see your face, you can see my face, or whatever, right? I would actually just want to have some friends like that. Okay, I don't know, maybe Facebook, maybe Instagram, maybe other software. I really want to do it live. Okay. So next one, matrix multiplication. Right? Next topic, 1.7. 1.7. Oh, my pointer is not okay. Aha, it's okay now. 1.7. We want to multiply the matrix. This is like the third operation, right? Third operations. The first one, we talk about the addition already. We talk about the subtraction already. So this is the third one, it's the multiplications. Okay, let's do it. Let's go here, right? This is like the rule. They are the rules actually. So we go like this. Rule number 1, right? If you want to multiply any two matrices, the rule is in the dimensions. So if matrix A has the dimension like this, 3 m rows and p columns, and in matrix B it has p rows and n columns, the rule number 1 is this two nearer number, these two closer numbers, they have to be the same. If they are not the same, you cannot multiply the two matrices. But if they are the same, nothing can stop you. You can multiply it, okay? Second rule. When you can multiply something, of course, you will get the answer, right? You will get the answer. And then your answers will be in the sides of this. You know, right? The two outside numbers. We have the inside numbers and we have the outside numbers. Okay, this will be the size of your answers. This will be the size of your answers. Okay. So let's see. I think that I have the example on the next page. So let's see how it goes. Okay. Oh, it's a little bit like lacking now. How to find a product of two matrices. Okay. So we have like two matrices like this, right? Let's call this one matrix A. Let's name it A. This one, let's have it a name of B, and this is the result. Let's give it a name of C, right? So remember the first rule, right? You have number 3 there. You have number 3 there. The two closer number, they are the same, right? The two inside number, they are the same. So it means that you can multiply A with B. No problem, right? You can multiply A with B. And of course, you get a result, right? So the result is the two outside numbers. So this number 2 and this number 2. They will be the dimensions of your answers, or dimension of your box. Dimension of your box, like 2 by 2, right? 2 by 2. So 2 by 2 means you have like 2 rows. One row number 1, row number 2, and then 2 columns like that. Okay, so let's complete this one, right? So when you want to find M11, right? M11 is here. M11 is here. You have like 4 members. So M11 is at location of like row number 1 and column number 1. So what you do, you multiply this row number 1 of A with column number 1 of B. Okay. Row number 1 of A, column number 1 of B. So we go like this. R11 multiply with C11. That is why we have this. Okay. This one. So next, if you want to find M12, right? Position of this M12 is 1, row 1, column 2. And then you go back there. Multiply row number 1 with column number 2. Okay. So that is why you have I'm sorry, I forget. I need to explain this one more, right? So let's go back a bit. Let's go back a bit, okay? R11 times, sorry. Yeah, I multiplied it already there. Okay. So I think that you get an idea. I don't know, like kind of headache. Okay. Next, we go like M12, right? M12. Row 1, column 2. So we just multiply like R11 with C12. Okay, so we have like R11, C12, added with this R12, and then uh, C22. Okay, R12 and C22. All right, next one. The first row of this, and then this member, right? R13, and that C32. C32. Okay, you get it now, right? So let's go a little bit more, right? So you get more of it. You can see it clearer. M21 precision is at row number 2, column number 1. So what you do, you have to multiply row number 2 with column number 1 there. Row number 2 with column number 1 there. Then you are going to have like R21 multiply with C11. And added with R22 multiply with C21. R23 multiply with C31. And all of them you will add together. You will add them together. So let's go. Let's see. Like, let's write it down. R21, C11 added with R22, and then C21, right? And then R23 and C31. Okay, so you I think you see the picture of it now, right? It's quite clear to you now. This one M22, M22, right? M22. So you go like R21, C12, added with R22, C22, added with R23, and then C32, something like this. So kind of complex, right? But actually quite easy. This one looks complex because I use a symbol. Okay. So let's go. Let's go to see this one. Okay, this is quite easy. This is like a good example. If your matrix A has a dimension of 1 by 3 and matrix B has a dimension of 3 by 2, you look at them, right? The two closest number, they are the same. So it means that you can multiply them, of course, right? And then the result, see your answer, we have the dimension of 1 by 2, something like that. 1 by 2 is 1 row and 2 columns, so it looks like this, and it has, you know, right, 1 here and 1 there. Yeah, it has like two members. So next one, right? Okay, next one, right? If you swap them, right? If you swap them, at first you have A times B, and then you want to swap them to B times A. So B is moved to the front with the dimension of the same dimension of 3 by 2, right? And A is moved to the back with the same dimension of 1 by 3. And if you look at this, oh my God, like the two closest number, they're not the same. So you cannot multiply them, and then, you don't have the answer. Then you're happy because you don't have to do anything, right? You can just go next to the other problems. Okay? Very easy. So in the exam, right, I know you expect something like this. You don't want to do this one because this one has more steps. This one is a little bit of steps, okay? Okay, this one is quite easy. This one just, I just want to tell you that matrix, right, for matrix, you cannot switch the order of them, right? You cannot switch the order of them. Okay. A times B is not equal to B times A. This is not like the numbers. This is not like the numbers. Okay, this is not like the number. Okay, next one, right? Okay, now we're gonna work with the numbers. We're gonna work with numbers now. Okay, no more variables. Okay, but sorry, you know, I cannot just go straight to something like this. Sometimes we need to focus on the concept and theory a little bit. Okay, so let's see. Matrix A has 1, 2, 2 rows. So 2 rows, and then how many columns? 1, 2, 3. So 2 by 3. That is the dimension of it, right? This one matrix B, 1, 2, 3, 3 rows, 1, 2, 2 columns. So 3 by 2, the size of it. And then you want to find A times B. Check this, check it out. All right. You have to check it out. Yeah, check it out. Yeah. These two numbers, they are the same. And they are the same. You can multiply them. And then the sides of your answers will be this number and that number. It's 2 by 2. So matrix, the result there, right, will come out to be like this. Ship, 2 by 2. 2 by 2 has like 4 members. So I can just go like that. I know I'm going to have 1, 2, 3, 4 there. So the first one, right? I want to find the first one now. This is the position of row number 1 and column number 1. So what do I do, right? What do? I want to find this one. I have to multiply the row number 1 of A with the column number 1 of B. So let's do it. Let's do it. Like, let's multiply them. Let's multiply them, right? Okay, position by position. The first one, with the first one, I have -2 now. Okay, let's write it down there. Then the second one with the second one, like 2 times 4 is 8. So I have number 8 now. Okay, add them up. Okay, next one, like the third one and the third one, -1 and 2, that is -2, right? Add them up, right? It's -2. Chip. Yeah. Okay, nothing is wrong, right? Okay, add them up. So you have it equal to 8 minus 2 minus 2, that is 4. Okay, so you're done. You have the answer for that first member now. For this guy, right? At the position of 1, 1. So next one, the position is 1, 2. So what do? You multiply the first row with the second column, this guy. Right? First row, second column, first row, second column. Easy. So let's go. First member with the first member. 1 times 5 is 5. Okay, next one, second member, that is -6, -1, and 1, right? The third members, that is -1. So final result, 5 minus 6 minus 1, that is, I think it's -2. So you write -2 down there. -2 down there. So the third one, right? We go to the third one. The third one is row 2, column 1. So multiply row 2 with column number 1, like this. Okay, so you go. 3, 2 is -6. 1, 4 is 4. 4, 2 is 8. Add them. Okay, that will be -2 minus 2 plus 8 is 6. Right? Last one is that positionally 2, 2. So multiply second row of A with the second row of B. So let's go. 3 times 5 is 15. 1 times 3 times -3 is -3. 4 times 1 is 4. Add them up. Show what is the result? That is 12, right? 12 plus 4 is 16. Yeah, so you have them now. Right? You have the answers. But you know, right? This one is like to ease the calculation, to make it easy. But actually, you don't need to write this. You don't need to write this. I expect you in exam to let me know just a number like this: 4, -2, 6, and 16. You don't need to write down the dimension of them. Okay. So you kind of understanding it, right? Okay, next one. Oh my God, this one is not gonna be easy. It's not gonna be easy. So how can we make it easy? I know. A is 2, 3, -1, and 4, something like that. We want to find A square. This one has dimension of 2 by 2. 2 by 2. This one has a dimension of 2 by 2. Yeah, you can multiply them, right? Because this number and that number are equal, and then your result will come out to be like 2 by 2 because of that 2 outside number. So you will have like 4 members. Okay, let's start. The first one there, right? The first one here, not there. The first one here, you will get it from the first row multiplied with the first column. So 2 times 2 is 4, and 3 times -1 is -3. Then you do 2. Oh, no. Okay, let's do it again. Like 2 times 2 is 4. Then 3 times 2 times 2 is 4. 3 times negative 1 is negative 3. So 4 minus 3 is 1. Next, I want to get this. This is on the first row, but second column. So I go to the first row, like 2, 3, multiply with the second column, 3, 4. 3, 4, right? I go 2 times 3 is 6. And I go 3 times 4 is 12. Add them. I have 18. I have 18, right? Next one, this, I'm on the second row now, but I'm still on the first column. So I go first, second row, right? Second row, multiply with the first column. Okay, I go negative 1 times 2. I have negative 2, right? And then 4 times negative 1 is negative 4. Yeah, I have negative 6 there. Right? Okay, next one, the last one, right? Last one is row 2, column 2. So we go quickly like this row and that column. So we are going to have that is negative 3, right? I'm gonna write it here, negative 3. And then 4, 4 is 16. 16. That is 13. That's 13. That is 13. Yeah, finished now, right? Okay, next one, you want to find a cube. You want to find a cube, right? So what do? You just have to copy a squared that you have here. You have the a squared there. You multiply with one more a, right? A squared and a. You will have a cube there. You will have a cube there. Okay. You have a cube there. Okay, let's do it, right? Copy and paste. 1, 18, negative 6, 13. Uh-huh. Multiplying. Let's do it, right? Okay, first one, first row, first column. 1 times 2 is 2. 18 times 1 is 18 minus something. So you have negative 16. Negative 16, right? Next one. First row, second column. That will be 3. And that will be 18 times 4 is 7. Yeah, 72. Yeah, 72. So you have to ship add them. That will be 75. Right? And then let's go next one. This and that. That will be negative 12. And then, right, second row, first column. 13 times negative 1 is negative 13. So you plus that, you add them. It will be negative 25. Yeah, negative 25. The last one, right? Second row, second column, that is negative 18. And then 13 times 4 is 52. Out of 52, right? So you should get 4 there. And then that will be 34, right? Yeah, I think it's 34. Okay, let me drink a little bit of water. Okay. You know, if you have to talk alone and talk a lot like me, you will feel like water is more valuable than gold. Okay. Okay, let's go next one. Next one. Find the values of x and y, and you want to find the values of x and y, right? We have matrix A, we have matrix B, and AB is A times B is 12 and 6. And you have to find a missing number x and y. Okay, you have to find a missing number x and y. Okay, I'm gonna zoom it in a little bit. Okay. Let's do it. A times B. Can you multiply them or not? Let's check it out. 2 rows, right? 1, 2, 3 columns, 1, 2, 3. 2 times 3. Okay, 2 by 3. And this B, 1, 2, 3 rows, 1 column, 3 by 1. Oh yeah, this and this, they are equal. Damn, you can do it. So If they are equal, you can multiply them, and then your result, we have the dimension of is 2 by 1. 2 by 1 means 2 rows, and then 1 column like this guy, 12 and 6, 2 by 1. Okay, so let's see it inside and how to find a missing number, right? So let's go. I'm gonna write a big one. I'm gonna write a big one on the left, right? So how do you get your 12? 12 is at position of row 1, column 1. So you multiply this row 1 with this, yes, column 1, the one and only column 1. Like just multiplying it, okay? 1 times 2 is 2, and 4x times 4 is 4x, right? 3 times y is 3y, something like that. And then number 6, right? You can get it from this second row. It's multiplying with the first column, right? 2 times 2 is 4. Negative 1 times 4 is negative 4, right? 1 times 1 is y. And that will be equal to 6, right? The first one is 12, and the second one is 6. Okay, let's see. Simplifying it a bit. You don't have anything left there except this y, right? And y is equal to 6. You know that your y is equal to 6. You get your first answer now, Nick. Happy. All right, next one. If your y is 6, like, let's go back to that first equation. What do we have there, right? We have 2 plus 4x plus 3y, and it's equal to 12. So you move number 2 there. 2x plus 3y is 10, right? Move it there, subtract out 12 will become 10. And then y is 6, substitute y and change it to number 6. 3 times 6 is 18. 4x plus 18 is 10. 4x is 2, move it there. 10 minus 18 is negative 8. So x is 2. Move it to the right, right? This number 4 move to the right, you have negative 2. Yeah, you have your answer now. So y did 6 negative 2. Easy. Let's go next. Okay, so what is it, this one? What is it here? So 1.9, properties of matrix addition and multiplications. Okay, let's see some properties, right? But I think that I'm just gonna highlight the good one for you. Something like this. That letter T, right? If you still remember, that letter T is short for transpose. Okay, short for transpose. So what does it mean for number 1, right? It means that if you have A transpose plus with B transpose, this T and that T, it's like the common factor. They work like the common factor. You can just pull it outside. You can just pull that 2 T's outside to be 1 T, right? And then you just have to find A plus B, and then you can transpose it later. What is transpose? Transpose, you have to change the row to columns, and you have to change the column to the row. Or I can just say like swap, okay, swap. Okay, so this one is a good one, right? Next one, A plus B is equal to B plus A. Straightforward, very easy. Okay, third one, associative, right? Associative means, right? Associative, you can chain a group. You can chain a group. When you associate with new people, you need to chain the group, right? If you stay in the same group, you will not associate with new people. So you have to chain the group. That is why we call it associative. Changing the group. Changing the group. But anyway, result is still the same. Okay. Additive identity. Yeah. Additive identity is that metric 0. Very easy. Yeah, we go. Commutative. Yeah, I forget to talk about a commutative, right? Commutative. If you still remember, right? This C is short for like change, right? Change, and that O is short for order, right? Change order. So A plus B and B plus A. You can change order, move something to the front, move something to the back, but you cannot change the result. The result is always the same. Okay, this one, A plus minus A is metric 0. So negative A is called the negative of A, something like this. Very easy. It's just, I don't know. Yeah, easy. Uh-oh. Properties of scalar multiplication. Okay. This thing is like the highlight. Okay. Sometimes you have to use them. Sometimes you have to use them in exam, right? Some exam is like really hard if you're trying to do it directly. So to avoid that difficulty, to avoid wasting a lot of time in just one single problem, so you need to apply some properties. So this guy, right? This guy, if you have k times a, k is a constant, k is a scalar. You multiply with a and you transpose it. Is it equal to that? You know, it is equal to that k multiply with a transpose. It means like transpose before multiply with k. It's the same as multiply with k first and then transpose later. Yay. So you have to use it sometimes in the exam, right? This one as well, right? You have two constant k1 and k2, right? You can swap them, right? You can swap them. Okay. Constant is having commutative properties, so you can swap them. K1, K2, you can swap to K2, K1, and you can even combine them into the same group, like K1 times K2. Quite easy. This one as well, right? This constant is distributable. So it works like normal number. Very easy. Yay. And then next one, like this one, transpose this guy. I have the star, right? I have the star for it because transpose, if you distribute it in multiplicative, it's okay, but you have to switch the order. From AB will be BA, okay? From AB will be BA. You have to swap it, and then never, don't forget about this, okay? It's very important. It's very important. Yeah. And then next one, right? A times B might not be equal to BA. They don't have to be equal, right? Nothing is guarantee the equality of them, okay? Associative, yeah, associative. I tell you, chain the group, right? Chain the group, associate with new people. Chain the group, easy. You can chain the group. A times I times A, and is equal to A because you multiply with identity. This A, this I, right? This I works like number one. It works like number one, you know. This I is identity matrix. It works like number one. Number one times anything, you know, number one times anything or anything times number one is that same number. Okay, we go next slide. What? I want to use that. Sorry, not number four, right? So A times A inwards is equal to A inwards times A, and it's equal to the identity matrix. Maybe you don't know what is A inwards now, but soon I will explain it to you later. You know, A inwards. Yeah, maybe I talk a little bit like A inwards is like 1 over A. A inwards like that. And we'll talk about it later. And associative properties of matrix multiplications, blah, 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 right? This one, it has something. If you have A plus B times C, like that, C is at the back. So when you multiply, you distributive inside. C has to stay at the back, okay? C has to be at the back. C cannot go to the front. Yep, and alternatively, if C is at the front, you distribute it inside to A and B. So C has to stay in the front. Okay, you cannot just move C to the back. C, I don't know. You cannot have like a freedom. You're gonna have like freedom to do whatever you want, right? Because metric, you know, right? You cannot switch the other metrics of the metrics. Okay, next one. Yeah, let's see this one, right? I just say that if you switch the order of metrics of two matrices, then the result might not be the same, right? So this one I want to find A times B, and here we want to find B times A, and we want to check that they are equal or not. But if you look at here, I say that they are not equal. They're not equal. Like, but let's see. Okay, let's see that they are not equal. But by how? Right? Okay, multiplying. Okay, 1 times 2. 1 times 2 is 1 times 2 is 2, right? 2 times 0 is 0. Then you add them up, you have number 2. Right? Next one, I want to find this first row, second column. 1 times 1 is 1, 2 times 1 is 2, 1 plus 2 is 3. Okay, I got next one, right? Second row, first column. Second row at here, I see is here. First column is here. I will have -2 plus 0, that's -2. And then that one is -1, 3, that is 2, right? So that is my AB. Let's find BA. Let's see how is AB. How is AB? No, let's see how is BA, right? If we switch the order, we move B to the front, we move A to the back. Okay, let's find it. Chip, chip, chip. Do it now. 2 times 1 is 2. That is -1. So 2 minus 1 is 1. Maybe I can just stop it here, right? Because you can see that the first one is 2, right? This the first one of this matrix is 1. I don't even know what are the values of the other 3, right? But I know that 2 and 1 cannot be equal, so I can just stop here and I can just make a conclusion, right? With the thick letters that AB is not equal to BA, right? So matrix, you cannot change the order for the multiplications. You know, it doesn't work like the numbers. Okay, next one, right? I would say like this one is quite like classic. This one is quite classic because I feel like, you know, I have been a teacher for like long time, right? I have seen this kind of thing in exam many years, right? Because you know right away, right? If you are a good student, you always listen to the teacher. You would know that a plus b squared will be equal to something like that, and then you can just have it like memorized in your memory. Something like this will become, yeah, entirely little bit, sorry, like หน้ากำลังสองบวกสองหน้าหลังบวกหลังกำลังสอง right? You would call it like that. You would spell it like that. Okay. But anyway, สองหน้าหลัง is that here, right? And you know that AB and BA in matrix, they cannot be equal, or they can, but very low possibility to have them equal. So somehow that will not be equal to 2 times of AB. Okay? Same like this one. Negative AB and negative BA, very low possibilities to have them equal. So you will never have like 2 times of AB. So if you see this one in the exam again, don't fall in the trap. Don't let them kill you, okay? Shup. AB, BA. Now we're gonna do it here, right? In some case, you are very lucky. Some case like this, when you multiply AB and BA, right? Sometimes you can make them like equal. Or not. Okay, let's check it out. You want to find AB, right? So A times B, A times B. So first one, right? Do you have to multiply that? First row, first column, 3 times 1 is -12. 5 times 2 is 10. -12 plus 10 is -2. Right? -2. Oh, I got some message again, but I'm not gonna. Yeah, I'm gonna leave you. I'm not gonna leave you. Okay. Let's do more of it. Okay. Let's do more of it. And then next one, right? I know. I think that we will not do like all of the AB, right? We will not try to finish all of the things in AB, but we will do it at the same time with BA, right? And we will just compare it like one by one, right? One by one, right? We just compare it one by one. Okay, let's see BA, right? You want to get the first member of BA, then you go first row, multiply with the first column. Okay, -4 times 3, that is -12, right? And then 2 times 5 is 10, so -12. And 10 is -2. Uh-oh. First one equal already, but that is only 25%. You still have to do more of the other 75%, right? Okay, this one, right? First row, second column. First row, second column. Let's see. 3 times -10 is -30. 5 times 6 is negative, it's 30. So negative and positive 30, it's a 0. Okay, next one, we go. We compare this one. We're gonna compare it here in BA. That is the first row, second column. right? First row, second column. Again, -4 times 5 is -20. And here is -10 and -2. Multiplying, you have 20. Okay, -20, +20. It's 0 again. Whoa, it's equal. Two of them now. Let's go. 50% now. Let's go next one, right? This one, second row, first column. Shoop, shoop, multiply, right? That is 4. That is 4. No, that is 4, right? -1 and -4, that is 4, right? -2 and 2, that is -4. So 4 minus 4 is, again, 0. This one, second row, first column, 2 times 3 is 6. 6 times -1 is -6. So 6 minus 6 is 0. Oh, three of them now. Three of them now. All right, 3 of them now. Okay, let's see. Next one. The last one, eh? This is the second row, second column. So you go second row, second column. That is 10, right? -1, -10 is 10. -2 and 6 is -12. So 10, -12. Add them. It's 2, right? 10, -2. -2. Okay. Last one of BA. Second row, second column. That is 10. And then 6 times -2, -12. Okay, you have the same thing. You have the same thing. Whoa, so here AB is equal to BA. But I would say that very, very few chances, very few chances though you will see them equal like this. So I would say that like exam usually asks you like, is AB always equal to BA? Then you have to answer no. You know, sometimes they are equal, but most of the time they are not equal. Not always equal. Okay, so be happy with that. Okay, be happy with that. Hey, and one thing I tell you, if AB is equal to BA, you will always have, you know what, this one, diagonal matrix. The result will come out, it will always come out to be like the diagonal matrix. Yeah. You can just observe them. Okay. Next topic is determinant. Next topic is determinant, right? Yeah, so what is the determinant and why do we have to talk about this one, right? So determinant, like as the name state, right? Determine, you know, right? Determine and determine and determinant. So when you do determine, right? When you determine something, right? When you determine, it means like you trying to check something, right? And means like a tool that you use to check something. So determinant means like checker, something, you know, a thing that is a tool to check something. Okay, a tool to check something. So what do you use to sorry, I have running nose. I'm a little bit sick now. I'm not gonna stop. Okay, I'm gonna do more of it. I promise you already. I will make videos. Okay, so determinant, it's like a scalar, and you're gonna use that value to check whether your matrix has an inverse or not, you know, right? It will have an inverse or not. It depends on the determinant, and I'm gonna tell you later how to use it to check whether your metric has the inverse or not. Okay, and that is a symbol. Maybe you call it like det A with brackets. Maybe you call it det A like this with without the brackets. Or maybe and sometimes we use something like that. That is not the absolute. Okay, that is not the absolute. It doesn't mean that you have to change like all the negative into the positive, but it means determinant of matrix A. Okay, that is the shortest. So people usually use this one and then yeah, this one, right? But I don't see this one very often. Okay, it's long, right? So let's see this. For a 1 by 1 matrix. That A, determinant of matrix A will come out to be the same as the member of it, right? Choo, very easy. Next one, example, yeah. A is 3, right? So that A is 3, B is -2, that B is -2. If you use a symbol like that, that A is 3, then that B has to be -2. Sorry, it has to be -2. Copy and paste. I'm sorry. Copy and paste. Okay. It to be -2. Okay, fix it a bit. Okay, this guy, right? For a 2x2 matrix, you have like 4 members there. You have 4 entries there. To find determinant of A, you have to swap something a little bit. We say, and yeah, we use a shortcut like this to find it, right? You have to multiply down. You have to multiply it down. You get AD, right? And you have to multiply it up like that. You get the BC. And then we say something like multiplying down minus multiplying up. So you are going to have like AD minus with BC. That is how to find a determinant. Okay, that's how you find your determinant. Okay. I think when I finish this topic, I will stop. Okay, because I'm quite hungry now. I want to have my dinner. This is like what time is it? Like 8:23 p.m. now. I'm quite hungry now. Okay, when I may go to have my dinner, and then I will come back to explain to you more about the minor later. Okay, so C looks like that, right? Determinant of C. Let's find it. Okay, cross down is 4, right? Cross down is 4, cross up is 6. So what you do is cross down minus cross up. That will be -2. So that C is -2. Right? Next, you have to find that D. But there I wrote E. I'm sorry. That should be matrix D dog, right? So what do? You cross down. It's -6. You cross it up there. It's -6. And -6 minus -6, we have it equal to 0. Right? Determinant. Okay, maybe I'm gonna write it down. -6 minus -6. That is 0. Okay. Now I tell you, if the determinant is 0 like this, we say that your matrix, this matrix doesn't have the inverse. This metric doesn't have the inverse. If the determinant is 0, and we call metric D as a singular matrix, singular like single, no girlfriend, no boyfriend like that, right? Single, okay. But if the determinant is any value non-zero, any non-zero values, it has the inverse. Okay, so CCAT has the inverse. Okay, CCAT has the inverse. Yeah, right? So next topic is minor. It's quite easy. And then cofactor. It's also easy. But anyway, I'm very hungry now. I'm gonna go to eat my dinner. I will see you soon, okay? Have fun. Bye-bye.